my lovelies, we are starting the third week of our programming course. And the idea was that last week everybody read and understood the first chapter of the very famous Koenig and Ritchie C book and wrote all of the examples in their GitHub repository so that we're now all of us entirely aware of every single thing that's going on in that first chapter. And we would ideally today be able to carry out some simple exercises based on what happened in chapter 1 and then actually define a programming assignment that we could work with. So let me get to the repository. Let's get rid of all my files here. So you can either be looking at my repository or ideally someone else's repository. The best thing we can do learning-wise is everybody always stare at somebody else's repository so that you can look at what other people did. And let's go to the website so everybody gets one. So we'll go to the website of the class, copying it here. Find yourself on this list and click on the repository right underneath you. If you are Wakamoya, you click on the very first one. So everybody opens somebody else's, and that somebody else is the person right underneath you. If the repository right underneath you isn't working, let me know and we'll figure out what it is. If your own repository is listed wrong or double, we need to fix those. I have 2 boss masters right now. Let's go fix that one first. They seem to be the same. Let's get rid of that. So everybody opens the one right underneath them. Let me know on the channel if you have any trouble. Let's see if Ags actually did something. No, he hasn't done anything. Let's get rid of Ags. So if you are Diego, you are now looking at Edgar's repository. If you are Edgar, you're looking at Emilio. If you are Emilio, you're looking at Eric, etc. This is the web page of the class. I have linked it today, and it's also pinned on the channel. It's the oldest pin on the channel. I am going to put another poll. If you opened the repository of the person right underneath you, please click on the green thingy. If the repository right underneath you is in some way broken, please say which one it is, and I can go either take it off the list, or if the person is here, we will fix it. And I'm just going to be opening random repositories at any given time, so I'll be looking at different people's code in different moments. Okay, 17 people seem to be on board. Juanito, if you're not on the list, it's because I haven't gotten your repository. I really need it. If you're not on the list, you need to give it to me now, because a lot of other people need to change the one they're looking at after I add you. Because the person right before you is going to have to look at another one. So please give it to me immediately. Please, please, please. So we're not holding everybody up. Juanito, I need yours. I've been asking for the repositories repeatedly. For example, this afternoon I was asking if anybody is still missing from the list. We're waiting for Juanita. So everybody else is on the list. Everybody else was able to open somebody else's repository. Okay, creator is gonna go over here. Let's copy this, put it here. Nito 7, close link. Remove cat from keyboard. Close item. Save. Refresh. So now if you are Cesar, you're supposed to be looking at Juanito instead of Daniela. And Juanito is supposed to be looking at Daniela. So now everybody's okay? Okay, I'm gonna open a random one. This one here. What we're first going to try to figure out is where is their Hello World program. There's a thing here that's called Hello World, but it looks a bit weird because it's not .c. So we're gonna look at it. Looks fine, but the name of the file is kind of weird. So let's make a comment if we can. I don't think I can. Here we can see who did what at which point. There is an issue. I'm going to make an issue. Please name the file something like hello.c. Or actually, please rename the file. Okay? So everybody try to find the Hello World program that just prints Hello World of the person whose repository you're looking at. And if there's any trouble, Bossmaster, your repository was there twice. Okay, so maybe I took it out the 2 times because it was literally there twice. Give it back to me and I'll put it back. But seriously, if your repository is already there, you cannot just post the link because I will just add it and then it's there twice. If you need to make a correction, it's very important to tell me that you're substituting a previous one. Okay, now we're waiting for Bossmaster to give the repository address. I swear it was there twice, like 5 minutes ago. Copying again. Really hoping that next week we're not going to have any changes in this list anymore. So now if you are Brian Sotelo, you're going to be looking at Bossmaster. Bossmaster is going to be looking at Cesar. Returning to the list. Reloading the list. So everybody's good now? And everybody found a Hello World program? Things we're looking for in the Hello World program is we're trying to make sure that the person is including the library correctly. There needs to be a main method and there needs to be a printf. The f comes from formatted printing. And ideally the printing would end in a \n. If you think the code might not compile, you're more than welcome to try to compile it. We could actually try to use the online thing. So I'm going to open the online GDB in another one here. I'm going to go to raw. I'm going to take Hector's code, supposing I had any question about whether it's going to compile. I think this code is just fine. I paste it here and I run it. And I always forget to choose the language every single time. Language. Oh, it's because my browser is always too small. Come on. I need to stop zooming into things. Language C, run, and it's fine. And if it isn't fine, you can copy whatever is wrong with the program and you can make an issue to tell the person what's wrong with their code. If you're collaborating with someone more than just checking one code, you could actually clone their entire repository to have like a local copy of it. And if you want to work with them, You could ask them to add you as a contributor so that you could both be working on the same code. If you're not sure if something's okay, try compiling it. I really like this space here. I really like having the parentheses here. I really like having this thing on the same line with the main. Some people like having it on a separate line. If you're not sure if something's okay, go compile it. If it runs, it seems fine. These details are style preferences, and some companies have like a style code, like a record of how you're supposed to make your code look like, so that everybody does consistent formatting on their code. But many different ways of placing things work just as fine in C. So let's make a poll. If you are able to locate a Hello World code and you either concluded it's okay or made some remark on what's wrong with it, put the green check mark. If you need more time, put the confused face. If you barely just showed up and don't really know what we're doing, pick the last one. If you have a question I need to answer, please click on the interrogation so we know how to wait. The question mark, the red one. So if we've read this part of the book, we should now know how to make tabulators, how to make backspaces, how to make double quotes, and how to make backslashes. So if you start to struggle typing those kinds of things in your code, remember that's all in section 1.1. Now we're going to look in the repository for the person's Fahrenheit code. I'm going to pick someone who isn't Hector, so I don't pick on Hector the entire time. Okay, we have a problem here. This person doesn't actually have a repository. This is just a profile. So let's tag the person. I'll show you in a moment how I made the comment. Let's take this one here. Okay. Again, I have a problem with the file name. File names that contain spaces are kind of like a bad idea, so let's make a comment of that after we take a look at this code. I'd like to have the main, but its absence doesn't really do a bad thing. This is an integer variable, but we're printing it here as if it were a float, so this is... No, actually we're printing it as an integer, and this one as a float, so it's fine. So we go from 0 to 300 inclusive in steps of 20. We didn't put the curly braces on the 4 because it's only one thing, but for legibility it would be nice to have this code a little bit further to the inside. So really the only problem here is that there's a white space in the name. So I'm going to go to issues. I'm going to make a new issue. Please avoid white space in file names. Okay, thanks, bye. So when the person fixes this, they could mark the issue as closed. Okay, so Kigri has the same problem. I will need the repository Kigri to be able to replace it on the list. We should actually take notes here. So nobody should have a profile, everybody should have a repository. Let's look at this if we find people who have the same issue. Most people were kind enough to make a repository called C. This one's called C-. Programación estructurada. Moises made one that's called Moi. Yeah, here it's the same thing. Others look fine. A lot of people use their name for the repository name. The curly braces have a significance on the whiles and the fors. They signify the beginning and the end of what code goes inside the while or the for. We're going to be looking at that later on. If only one thing goes inside, those are optional. You don't necessarily have to put them. But if you have more than one command inside the cycle or the if block, you need to put the curly braces. So things to look for in the Fahrenheit ones. Okay, Damien hasn't done anything. It's kind of sad. Let's pick another one. Okay, so we're now in the section 1.2, this one here. Stuff we want to be looking at is that we want to be looking at the variable declarations, we want to be looking at the value assignments, we want to be looking at the calculations. And if you think that it's kind of hard to read, like for example, I'd like a space here, I would like this thing to be at the same level with the W. I'd like a space here too. I like the code works, but like I really want to have a space here for consistent punctuation. And everything looks just fine. And remember, if you want to know if it actually runs, go to raw, copy the whole thing, go here. Don't do what I do what I say. So language is still C. We can compile it. And we're going to see the entire output right here. I'm trying to interact with this bottom part here. I feel like this should be, there should be something here where there's this dot. I'm not sure what's going on. We'll find out in a little bit when we get to the input part. So, okay, let's see if we have any questions about the, the \T's are tabulators. They're not exactly a space, they're like a long space that does like alignments. It's a very 80s kind of a thing. If you want to change CPP into C, what you're going to Google is how to rename file in GitHub. And that way you go change it from the C to a, from the CPP to a C. But Montserrat, that thing that you're asking, the difference between the \n and the \t, it's in the chapter we just read. Okay, let's make another little poll regarding section 1.2 of the book, which was the example of the Fahrenheit and the Celsius. Do we have any questions about this section? Edgar, if you put white spaces in them, there is a problem. I would go for something like E_1_1.c. Like I don't like putting the dots when it's not the file termination. The difference between float and double is the space on the memory that you reserve for it. Doubles can be twice as precise as floats because you're using more bits to store them. But both are decimal representations in the language. This is a much discussed thing. And to fully understand it, you really first need to understand the IAAA standard for floating point numbers. I'm pretty sure I actually have slides for this somewhere because I used to teach it to second semester students. Let's find it. Somewhere very far away. Computational algorithms. It's probably here. Nope, not here. But basically, I'm actually going to go to the whiteboard to explain this, how to store decimal numbers on the computer, because it's kind of important to understand. Okay, so when we're storing a decimal number on a computer, we're actually not storing the digits themselves. We're storing something entirely different. The system you're using has already chosen a standard exponent, and all the numbers are represented as a number multiplying that base to an exponent. And the base is a constant. Your computer shows a constant. It could be 10, it could be 2, it depends on the architecture. But there's a constant base. And you have some bits, a fixed amount of bits in which you will store this value m. And another fixed amount of bits in which you will store this exponent. So if you put more bits to the exponent, you can make the numbers much bigger or much larger according to whether you use a positive or a negative exponent. And when you put more bits here, you can make the number more precise because you have more, let's say, significant digits in your representation. But you're going to want to read up on this, especially if you're going to be a software engineer. I know we have a lot of different study programs mixed together, and like materials engineers are probably not going to want to know about this. But the floating point representation is in terms of a base, a mantissa, and an exponent. You're not storing the what comes before and after the dot, you're storing the number this way. And the difference between double and float is how many bits you have for these fields. Okay, so now exercise 1.3 was to modify the program so that it adds a header to the table. Let's modify it right here. I can't remember whose code it is, but we're modifying it anyway. Okay, so I've added one print in front of the thing. I'm going to make the changes because it's getting on my nerves that it looks like this. Making some other little changes too. Moving this here. Moving this here. Putting some spaces here. Putting some spaces here. One here. If these are all double, well, it doesn't make any sense that they're double because they're clearly integers underneath here. Let's move this here. Let's take out this comment. Kind of want to make these defines. Let's make these defines so that they get optimized on compiling. I can't remember. Now when you define stuff, it's usual to make them, come on, uppercase. And I think when it's a define, we don't need these. Let's see if I broke the whole thing. Okay, apparently I didn't break it, but we can't see my lovely header. So we're just going to make the step bigger to make the table a little shorter and move this here. So now I have a table header. I just don't have enough of these little lines here. Let's make it a little prettier. Okay, now I have a table header. Now, exercise 1-4 was to convert the other way around. And the best way to, I have no idea what I did here. The best thing to do would be adding first the conversion the other way around, so that you know you're doing the math right. I'm just changing it because that's the way I like it. It does the same stuff, but I just kind of like it a little better. And you've already seen much of this stuff in sections 1 and 2 in the book. Much of this is like a question of taste. So I'm simply going to make two different f variables, an f1 and an f2. Let's call this one C. This one's going to be the f1. This one's going to be the C. F1's going to be the one that's incrementing. This is the F1. And now I'm also going to want to make an F2. I want to convert the Celsius back into Fahrenheit to check if I'm doing the math right. So it would make sense to multiply by 9. It would make sense to divide by 5. And at some point we're going to need to add stuff. So basically if I want to solve for F1 from here, I would first multiply by 9, then I would divide by 5. Let's say I multiply C by 9, then I divide the whole thing by 5, and then I would add a 32. This sounds kind of okay? Semi? Let's see what happens. Oh, my header is not really going to match it. Oh, I forgot to put the space for it here. So one tabulator and another print thing. Okay, so 0 goes to minus 17, goes to 0. 50 goes to 10, goes to 50. So now when the first one and the last one always match, I know my formula is okay. So basically, now since I know that my formula is okay, I could do like an if-else type of a thing to decide which one I want to use. Or I could make some kind of a like dual thing here. Let's make an if thing here. Let's make an int direction, and let's make it a 0. And I'm kind of indecisive about how to do this. Let's make a huge double thing here. Okay, let's copy this whole thing, make a second one of it, and put here that if direction 0 reads as false, any positive number reads as true. If it's false, we're going to do the original direction. We're not going to use the F2 here because this is the original direction. We're actually just going to use one single F at this point. So it's going to be the F that starts at lower. Until F gets to upper, we're going to be making the calculations for the C. I personally would prefer the for loop for this, but we're just modifying this code for now. We're printing these things out, and then we're incrementing the F. That closes the while. And in the other case, that direction wasn't false. Now I want to do the table for the Celsius. I'm going to start the Celsius at the lower. I'm going to print the table the other way around. While C is less than upper, I am now going to calculate an F from the C. And I am going to print first the C and then the F. And it's going to be the C that's going up by step. I will close. See how it makes this lovely little line here to show what all's inside the if? I'm very happy with it. We will close the else and return 0. I'm still unhappy with these spaces. Spaces in C don't mean anything other than mental stability for people like me who like stuff being at a certain position. That's the return, and that's where it closes. Let's see what all I broke. I have an F1 reference still somewhere. I'm printing 2 things even though it's only 1. I still have an F1. It's really important every time, just compile, read the message, compile, read the message. Eventually it's going to do the thing you wanted. So now it's going to pick one of these. Direction was, if direction, okay, but it is C, this is C, I should really actually compare it. This is C, this is not anything else, okay? So if direction 0, it's going to give me the table from Fahrenheit to Celsius. And if I put direction to 1, it's going to give me a table the other way around. Okay, Monse is confused. In the moment that it compiles and it puts certain values not in the part of the operation in the first column. I don't really understand the confusion. Is this still related to the floats and the doubles, or is this a different confusion? Okay, let's see in the repositories we're checking if the person actually did this exercise. I think this one only has the examples. It doesn't look like it has the exercises themselves. No, this one actually does. This one does the Celsius. It starts from the Celsius. It keeps incrementing. Okay, let's look at the one that adds the header. Yeah, this one just says conversion table. Conversion is misspelled. Let's tell them conversion is misspelled. ¿Cómo se pone de 0 a 300? Okay. What we're doing here is we're setting a variable that it starts at the value lower. And it's going to keep incrementing by steps of 50 until it reaches upper. I'm now going to write these as a for loop because it's a little easier to read. So we're going to get rid of this assignment here. I'm going to leave the second one as a while so you can compare. And make only the first one a for loop. So now I have the exact same logic. Up here it's written with a for. Down here it's written as a while. And I could also do this with less variables. I could put the expression that computes the value of C in here. And I could put the expression which computes the value of F right here. Should still do exactly the same thing. And if I change direction, it's going to run the other option instead. Now, since I'm not using the variable to put the conversion into, I could just use one single variable for temperature. So here I could put that T goes from lower to upper and T increments by step. And here I could also use the same T. But now, since the logic is like this, it's kind of beginning to feel like I should actually just do one loop and move the if to the inside of the loop. So basically I could move the header like this. that the header is going to print either that or this, according to what the direction is. And then inside the for loop, I could print the original t and then one of two values depending on the direction. So I could print that if direction was 0. Else I would print another thing. So now I'm doing what I call a mini if. Mini ifs are wonderful. The way in which you write a mini if, I'm going to write it in much larger letters here. Let's go to the repository, documents. Come on, exit. Let's make a mini if C. We need some kind of a printout so that you can see what's going on. I'm going to use a variable x. And here we're going to put that x is 3 if, let's see, 7 is smaller than 5, else it's 4. Okay, let's see if I remember the syntax is right. I almost never write C. Let's compile mini if. Come on. Compiling mini if. I did something absolutely horrible here now. Okay, I think I'm writing it the wrong way here. I think it's like this. If this condition is correct, then we do this. If it isn't correct, we do this. Let's try again. Okay, so 7 was not smaller than 5, so now x is valued 4. 7 is smaller than 15, so now x is valued 3. So what we're doing here is the same as if 7 is smaller than 15. Let's put those in variables actually, a and b. Let's put a 7, b 15. A and B, A and B, and let's print it twice. If A is smaller than B, then x is equal to 3. If it's not, then x is equal to 4. Compiling, running, taking a screenshot for you guys. So this is a very short way of assigning a value depending on whether something's true or not. Let's put it on Discord. There. So what I wanted to do here was that same thing. So if direction is 0, come on. If direction is 0, we are going to print 5 times t minus 32 divided by 9. And if it isn't, we're going to print 9 times t divided by 5 plus 32. And then t doesn't need to increment anymore because we're in the for. So now we have a very tiny program. Let's run it to see if I broke it. It prints from F to C when direction is 0. If direction has any positive value, any non-zero value, it prints the other way around. And it has a little table. Now what I don't like is the alignment here, that the commas don't always line together. To make them always line together, I'm going to add a 3 here between these things. Let's see if I broke it. Now I can't remember. Let's look at the reference card. There has to be a way to force the number of decimal places on the integer parts. I just can't remember it anymore. Minimum filled with, yeah, it should come before the dot. Left justify, print with sign. No, I don't want left justify. Not entirely sure why we have the else. Let's take those out. Why do you hate me, compiler? Yeah, if you put 7.4, you should have a fixed format 7.4. I'm wondering if it's this thing here or if it's my computer. Let's test it. I'm gonna call this two-way.c. Let's put the whole thing here. I had another one. Okay, let's do the mini if to the repository. And then we'll compile this thing. Still not doing what I wanted to do. So I wanted to give 3 places always to the integer part, even when it's smaller. So why am I not getting 3 places in the integer part, even when it's smaller? No, I didn't want to close it. I wanted to compile it here. If I make it always print the sign, it should show just fine. Let's make it always print the sign. I think that was with a dash. Nope. How to force integer decimal integer width. Fixed with integers. No, this is not what I want. I want to print them. Lol. Everybody says it's supposed to happen just like we think it does. First the how many integer places, then a dot. Maybe it works better if I force them as integers. Mysteries of life. Now these are floats, so maybe I could round them to the closest integer. Actually, let's just round the whole thing. And once I've rounded it, I still need to cast it to an integer because round still gives me a float. No, that's not how you cast in C. This is how you cast in C. Oh, and yeah, t is going to be an int now. Include the header math h, okay? Yeah, round comes from another library. So this guy gives us printf. This guy gives us round. Come on. Yes! Look at what it's doing now. They're now perfectly aligned. Okay, this is what I wanted to do. So now a quick recap of what the hell is going on in here. So what did I do? I'm using the math library to be able to round this decimal number to an integer. Then after it's rounded, it's still something 0.0. I'm telling it, please use it as an integer because I want to print it as an integer. That's what I'm doing. And why do I want to print it as an integer? Because I want it to align them on the right side, not on the left side. Okay, let's add this to the repository. Sending it in. And let's see how many people I have horribly confused with my solution to exercises 1 and 4. Remember, you can play with my code freely because everything's going to my repository. So it doesn't have to be crystal clear now. It would be really cool if you could tell me any questions you have about what's going on in here. I'll put it open here again, the two-way one, so that we can look at it. So programmers often refer to these kinds of variables as flags, that you set it to one value if you want something to happen and you set it to another value if you want something else to happen. And I'm using the same flag here, first for the direction, let's make it a little shorter, to print the header, and then again to choose in which direction I'm making the conversion. I'm saving space by using only one integer variable t. I think the compiler would even let me declare it here, but I don't want to be a dick, so I'm going to declare it there in the beginning. And I have two different ways of doing the math in terms of whether I'm going from Fahrenheit to Celsius or vice versa. And the next exercise, actually, the exercise 1.5, asks me to modify it that it doesn't necessarily go from lower to upper. It could also go from upper to lower. So we could also do that as a second flag. That could be like order, that could be ascending or descending. And we're going to use the mini if for there too. So we start in lower if order is 1. And if it isn't 1, we start at upper. Okay. And then we have a two-part condition here. It needs to be so that t is smaller to upper, while at the same time order is equal to 1. Let's put parentheses here to make this slightly clearer. So either order is equal to 1 and we're lower to upper, or we are greater or equal to lower and order isn't 1. Then we're going to add step. But what do I need to do with step? I need to change step to negative if I'm actually going down. So I am putting there step multiplied by if order is 1, I'm multiplying it by 1. If order isn't 1, I'm multiplying it by -1, so that it goes down when order isn't 1. And yes, this is purposefully horribly complicated. Let me try to compile it first. When it works, we're going to try to understand what's going on. Okay, so now order is equal to 1, and it's going from lower values to higher values. If I change the order to something that isn't 1, I recompile and I execute. Now it goes from higher values to lower values. So I made a second flag, and then I make the 4 start at lower if ord is 1 and upper if it isn't. The condition is going to depend on ord. If ord was 1, we're going to keep going until we reach upper. Whereas if ord wasn't 1, we're going to keep going until t reaches lower. If we're going upward, we're summing the step to the present value. If we're going downward, we're summing the negative step, which makes us subtract the step. So I'm going to take another screenshot of this while I also shove it in the repository, so that we can look at this in slight horror and understand that you can either make short code that does a lot of stuff, or long code that's much easier for a newcomer to understand, but takes many lines to express the same exact thing. So let's add TUAC. So now in terms of comments, this here is for exercise 1.3 that wanted to print the header. And the if part is for the 1.4 for choosing which one. Then here we added stuff for the exercise 1.5, the up or down. The first flag, the dir flag, is for the exercise 1.4, and the ord flag is for the exercise 1.5. Book actually doesn't use points, book uses dashes. So now I have a condition where I use the double ampersand to make two things happen at the same time, like I'm requiring two things to be true, and the bars to require either one side or the other side to be true. So I'm saying that if ord's 1, then t has to be smaller than upper, and if ord's not 1, then t has to be larger or equal to lower. And here we're using the mini if, where first we have the condition, then we have an exclamation, then we have the part that goes if it's true, and then we have the part that's going to be used if it's false. And if you want to see other ways of doing exercise 1.5 that don't use any new syntaxes, you are simply going to go see the 60 people who supposedly did it and see what they did. Let's see if I can find the tabla de conversiones encabezado, FCLUS, lower, upper. I don't think this one goes down. This one's, oh, this one's the one with the input. Did somebody make 1.15 that we would like to look at? Int can compile a name or just numbers. Okay, int is an integer number. So I don't really understand the question. The text that come there with int, those are variable names. Like these variables are called t, dir, and ord. And the only values they can take are integers, whole numbers, números enteros. A un int no le puedes poner ninguna otra cosa más que un número entero. If you want to store words in variables, we're going to need to use character arrays, and we're not quite at that point yet. But we could use the define for that, I guess, if we wanted to. But let's not mess with that, because I think this is complicated enough without adding text manipulation right now. Okay, so then the next exercises we're supposed to be looking at, they had to do with reading stuff from input and writing stuff to output. And it's possible that people had trouble with that, so we are going to try it here on the online compiler thing. I am going to see if I find anyone who did it. Lots of people have white spaces in their file names. Please, let's not do it. Okay, we're actually doing those kinds of things here. Okay, so I'm going to copy from raw this code from Hector. Has to do with the get char, put char part. If you actually haven't read this part of the chapter, you're not going to understand anything. It's really, really important that you read the chapter. Heraklitos, please wait a little while. We're just getting to this part. No. You can't assign Taylor to a char. Please don't do that. We're not at that part yet. Please don't put the name of the person to a variable like that. A character variable can only hold one single letter. So no, we're not going to do this. I can't figure out what I want to put there. Let's use this one. We're not doing it yet. We'll do it later. Please don't do it now. It's just going to make the code much more complicated, because we really actually have to talk about arrays in much more detail before you can start doing that. So hold off on the text, because this is C, this is not Python. Okay, so we were going to start looking at the get char and put char stuff. So where does get char take input from? Let's make this a slight bit longer. Well, shorter actually. Let's put that there. Let's add the return 0, because I like having a return. Let's make sure this runs. I've lost the part that I actually wanted to have. Okay, so expects int but has long ints. Okay, LD. Oh, I have to stop it because it's waiting for input. Let's put the LD here so it compiles prettier. Oh, you had a 1D. The 1 actually doesn't do what you want. You want it LD. Okay. Okay, so I wrote hola, then I wrote what's up, and then this program said 15. So now we need to try to understand what are those 15. There's 4 letters here plus the enter. That makes 5. There's 5 letters to what apostrophe? That's the 10. 11 is the S, 14 is the space. I don't think it actually counted the, because it's 4 plus the space, and this, that's a 12. 12, 13. Yeah, it counts them all. It counts the white spaces, the enters and the white spaces and every single character I put. So what am I doing here is that the get char is taking the stuff I write one by one and it's counting them. Then when it's all done, it prints how many it counted. To make it a slight bit clearer, I could add these parentheses here, and I could even make it print what it's counting. But let's change it a tiny bit. Let's make it so that it only counts the A's. So we would take a variable here, a character, let's call it C. We would assign whatever getChar gives to C. If it's not end of file, which is the Control D, then we're going to see if C is in fact the letter A, then we are going to increment the counter. Let's call it counter. And I really don't think I'm ever going to need a long for this because I'm not going to write that much. Okay, let's try to run this again. Oh. Okay, ahora voy a picar Control D. How many A's were there? There's 1, 2, 3, 4. There were 4 A's. So the program's looking at every single letter that I typed, checking whether it's an A. If it was an A, it increments the counter. And now it's not going to take uppercases. So it took this A and it took this A. It didn't take this one here. If I wanted it to take everything as if it were a lowercase, we need to look at the reference card again. And we would need to worry about how to convert things from one case to another. In ctype.h, we have a to lower and a to upper. So we could use that. I just need ctype.h. And I could put here that I'm going to use the to lower on C. So when I compare it to A, I will first force it to a lowercase letter, then I will compare. And now there's 3 A's because it made this lowercase before it compared. So that's what it's doing. And now if I wanted to use the put char that Kraklitos was a little bit confused. Now, please don't panic when you lose Wi-Fi. This is all recorded. Nobody needs you to be connected at all time. I'm making it finish by Control D. So now, if I, instead of counting things, I made something, I wanted to make something else, let's say it's a dad simulator. If I wanted to turn everything to uppercase, I could just make it so that we could actually do a put char to upper of C. Let's take this one away. Run this. Okay, so now I have a dad texting simulator. Everything I type, it gives it back to me, but in uppercase. I'm gonna take a screenshot from here. And I will put the dead simulator here on Discord. So it's beginning to look like not a lot of people did this second part of the chapter, because I'm kind of struggling finding people who have code referring to this part. Let's look at Pedro. No, this definitely doesn't look like it either. Ruben. I'm not convinced. Let's do an honesty poll. If you actually did the stuff using get char and put char from the chapter, you vote green. If you didn't do it, you vote confused face. If you tried to do it, but you messed it up and you have a question, select the question mark, please. Because these are really good exercises, and you're not going to be able to do the homework if you actually haven't seen these examples in much detail. Okay, so a lot of people kind of decided that they don't want to do this, so we're going to be slightly behind. When you get confused, you need to ask on Discord. Being confused privately is not reducing your confusion. Discussing the thing that's confusing you is a possible way of solving your confusion. But okay, let's quickly look at some of the stuff here with the online GDB. Exercise 1-9, for example, says write a program to copy its input to its output, replacing each string of one or more blanks by a single blank. So now I want to make a thing that instead of a dead simulator, while there's white spaces, it keeps skipping them, and then when there's no longer white space, it actually prints it. So I'm going to make a flag where originally I'm saying this is not a space. Then we're going to use from the C type, there's a function here for knowing whether something is a space. Where is it? Is space. So I can use the is space from the reference card. So here I could put that if is space C if, well then space is actually going to be true because we just found a space. And then if it isn't a space and we just had a space, then we need to print the space. If it isn't a space, we're printing the letter. But also if we had a pending space, if we had a space to print, we also need to put this space. And let's put them as underscores so we can actually see them. It's easier to note. And then we need to note that we have cleared the pending space. And we're not using the counter anymore. Let's try this. So now anytime my program encounters a space, it simply takes a note. Hey, this is a space, but it doesn't print anything. When it finds something that isn't a space, if there were any spaces, we're printing the underscore and we're resetting the flag that we've printed the space, we're fine now. Taking another screenshot. Please let me know in Discord if anybody actually wrote this exercise so we can go look at their code. Just say something like, I did it, if you actually did the 1-9. I'm operating under the assumption that nobody actually did 1-9. assuming there is a question coming. Let me put this on my repository as well, because you guys might need to look at it later. Gonna call it spaces.c. Okay. When you get confused, you need to try. You need to write some code. If it doesn't do what you want it to do, then you will post your code and you will say, I did this code, I thought it would do this and this, but it's not doing that. What's wrong with my code? Okay, let's try another one. 1-11 says, how would you, no, actually, let's do 1-12. Write a program that prints its input 1 word per line. So now let's modify this one here so that instead of adding the this thing, it's simply going to print it 1 word per line. This is going to be really easy. Instead of printing the underscore, we're just going to print a new line. And this is effectively going to print everything 1 per line, unless I'm high on drugs or something. Let's see. Hello, testing this thing. Woohoo! As soon as I clicked enter, it put everything on a single line. Because now anytime there's a space, I'm printing anytime there's something that wasn't a space and was followed by spaces, it's going to do a new line instead. So now it doesn't matter how many spaces I put. Let's do this again. Very nice. So now the difference between the 1-9 and the 1-12 was simply, instead of printing an underscore, I am now printing a new line character. So very small changes in a code can result in a different desired functionality. Now I'm a little worried about this array stuff, because if you guys kind of like gave up, then I'm not sure you're gonna understand these ones. Let's look at the schedule to see if there's any way we can catch up if we take 1 more week reading chapter 1. Because seriously, if you guys give up like this, we're going to be in trouble. We're going to be in trouble anyway, because we don't have enough weeks to do the stuff we're supposed to cover in the midterm. We're just going to have to pretend you guys actually read the chapter, because seriously, you need to start talking on Discord when you don't understand things, because we don't have time during the semester to delay just because you decided to skip stuff that I asked you to do. So we're gonna have to look at my code if nobody else wrote these things. Let me add the space thing here. So we want the digit counter example. The digit counter example is what happens in section 1.6. On most computer systems, you can produce an EOF, which means end of file, with a Control D. Or you could just feed a file straight to the program. Let me, I'm actually gonna close the online one now. And we can just use mine. I'll show you how to do this. Let's make a stuff.txt. No, txt. Hello, we are testing again this stuff. Okay, so now I could compile the space one, and I could run the space one and send it the file. So now, instead of me typing everything and using the Control D, it just put all of this stuff here. Here it's trying to actually print an end of file character. Here it's trying to shove it out. But I can send it from a file, or I can type and then press Control D. But okay, we're going to try to understand. I hope you guys at least read this, even though you didn't write it. But it's kind of important that you actually do these things. So in section 1.6, what we're doing is a program that counts in the input the digits. So what we're doing here is that I have an array of counters. And the 0 position is going to count how many zeros we've seen. Position 1 is counting how many ones we've seen, etc. up until position 9. So with the get char, I take the character and then I check if the character is between 0 and 9. And pay attention, it's a character, it's not a number. Then I calculate the index. And if I want the character 0 to go in index 0, character 0 isn't 0. Character 0 is an ASCII code for 0 that actually it has a totally different value. I can't remember what 0 is in ASCII, we should Google it. I think uppercase A is 65 in ASCII or something, but what's the value of 0? Let's look at a table. Okay, so a 0 is 48. So 0 is 48, 1's 49, 2's 50. So to make the 0 character map to index 0, I need to subtract 48. And this code has been written so that you don't actually have to know that it's 48, because I'm simply subtracting the value of the character 0. So I'm incrementing the indices here. Whenever it's a white space, actually we could improve this using the isSpace function we just talked about that comes from the C type. If it's an isSpace, we increment the counter W, and otherwise I'm incrementing the counter O. It doesn't matter if I do the plus plus before or after in this case. I could just actually put the index in here as well to make it a little shorter. Then I am printing out how many of each digit there were, and then I'm printing out how many spaces and other characters there were. Let's compile digit counter. Let's modify this thing. Hello, 1, 2, 3. We are 42. Again, 6 this stuff. 2, 3, 5, 7. Okay, so let's execute digit counter with the stuff. So there were no zeros. There was 1, 1, 3 2s, 2 3s, 1 4, 1 5, 3 6s, 1 7, no 8s and no 9s, a total of 17 spaces and 31 other characters in this file. So that's what the program is doing. It's counting the digits. And this code is given in the book. So all you had to do was secretary work. All you had to do was write was in the book. This didn't require any type of creativity whatsoever, only reading the book and typing what's in the book. But then exercise 1-13 is asking you to print a histogram of the lengths. So we could do horizontal bars. Like instead of printing how many, we could also make another thing print. We could print like hashtags, for example. We could do a 4. I need another index. Let's take a second index. For a j that goes from 0 to the I, j++. I could print hashtags, one by one, and then at the very end I will just print the new line. So now if I compile, no, this is not compiling. If I compile and run it again, now it draws me this tiny little histogram here. So this would be exercise 1-13. I know when you read these exercises, they sound like this is a horrible kind of work, like how can I never do this? But it's really just a couple of lines of code you're supposed to be adding to what the dude already did in the book. So it shouldn't really be too challenging. I saw someone working with the example code for the powers of 2. That I did see in somebody's repository. So there should be something going on there. I'm not even going to put a poll about this digit counting thing because I didn't see anybody's code there. And what section 1.7 is asking us to do is to rewrite the temperature conversion code using a function for the conversion. So we should have the temperature conversion code. Let's copy actually the two-way one. It's going to make a two-way F. So it's asking us to make a version of this code here that has a function. So we could make a couple of different functions in here. We could make a function that prints the header. And we could make a function that actually does the conversion. The header one needs to know the direction, and the conversion, it needs to know the direction and the value that we're converting. So we would move all of this stuff to the header, void header int direction. If direction 0, we print this, and then we just return with no value. And the conversion stuff, we could take all of this stuff here and send it to conversion. We're converting t in a direction, okay? T in direction. So we're returning a float. We're converting a value to a specific direction. So we are returning the int round. If d is 0, we do this. Let's actually call it v instead of value because I'm lazy. So it's going to be this one here and this one here. We don't need this comment anymore. Oh, we're actually returning an int because we're rounding it. So let's make this function return an int. So it takes 2 integers and it produces 1. And we are doing this for exercise 1-15. Let's see how badly I've broken it. So the point of functions is to separate some parts of your code to a more compact, reusable way to express things. I have an extra, there we go. So now it's still doing the same stuff. It's just moving the conversion code into a function and moving the header printing into a function. So that now the main program here, I'm going to remove these because they're already in the other file. So that the main code looks a little cleaner, and then we're going to go look into conversion when we want to know what the conversion thing's doing. And we're going to go to, I never printed the header. Let's add it here, printing the header. Like this. So now this code is a little easier to read because some of the logic has been separated into these little modules here called functions. So we're going to add this. Because we have just done the 1-15. And then we have the program of finding the longest line. And I really think you guys should do those, because when I do everything, you learn nothing. You only learn by doing. You learn nothing by watching other people do things. Like nothing at all. But I'm gonna make one more example implementation that has to do with exercise 1-23, which is how would you make a program that removes all comments. And now all the comments we have are of the type that there's a double slash and then there's a comment. But I'm going to make one of these comments of a different kind so that we can actually also learn to deal with the other kind of comments. This is a second way to make a comment. So now we're going to try to modify the long line code that I have to a code that's going to take a file and make the same file but without any comments. And we're actually going to use the two-way FC as an example. So the longest 2 is the one we're going to copy. I'm going to take longest 2. We're going to call it no comment C. And we're going to start working with longest 2. So this one does exactly what the chapter describes. If you didn't read the chapter, I feel really sorry for you. So what we have here is the length, maximum length for a line. We have two different arrays. We have one where we read the lines and another one where we put the longest. We're not going to care about the longest because we're just getting rid of the comments. So we have two functions, one to read a line and another to copy it. We're not really going to want to copy anything. And we're probably not going to need the thing to read it either. We are just going to, yeah, actually let's keep the function for reading it because it's a little, come on. Okay, so we're going to get lines from here. After we've gotten a line, if the line contains the comment symbols, it means we're going to ignore the rest of it. So basically, while we are getting the characters, we could be looking for any repetition of a slash. If we have 2 slashes, it means we want to ignore everything. So let's just make a counter here, an SC, which is a slash counter. And first add that if C is a slash, then we're going to increment the slash counter. Okay? If this was our second slash, we are simply not going to store any more characters because we're going to ignore the rest of the line. Okay? So as soon as SC reaches 2, we're going to stop copying. So we're only going to copy characters to the line that we're reading if SC is less than 2. When SC is 2, we are ignoring the rest of the line. So now what this thing should do is ignore the end of line comments, but not the other kind of comments yet. So let's try to print the lines. See how horribly I've broken this. GCC, no comment, C. Major. Oh yeah, I left the implementation for this copy thing that was underneath. And we don't really need to know what the length is. The other one needed to know the length. We don't need to know the length because we're not trying to find the longest one. So we can actually just read the line. No, but actually, yeah, it's a good thing to take the line that if we get an EOF, then we would stop reading. Oh, actually, no. What we are going to return is a totally different thing. We're going to return a 0 if we found an EOF. And we are going to null terminate and return a non-zero whenever we don't have an EOF yet. Okay, so we're going to return whether char is actually the same thing as EOF. So if it's EOF, it's going to give us a true. So if it's going to give us a true, it's going to be non-zero. So we want it to continue until and this is returning an integer because truth values are integers in C. And we're trying to print linear. We're not going to print the L because the L is simply the return value of the routine. Multi-character character constant. What am I breaking? Let's look at longest 2. Yeah, Majora it's printing just fine with a percentage S. We're not using this. We are using the linear. We're using the C, and we're using the I, and we're using the SC. Oh, but here we're using the linear, so it's an extern char linear because we're printing it. There we go. Why do you hate me? Incompatible integer to pointer. Oh, okay, I understand. These are supposed to be double quotes because this is C. Okay. In Python, you can just use simple or double and nobody cares. Okay, so let's send it some input. Let's send its own file there. So now I sent the same code to input to this program. And let's see what all it killed. So all the comments are gone, but it also died here. And why did it die here? It's because it found this slash. And what's the second slash that it found? On that same line. It should have found this one, and where's the second one? Why did it have two? Oh, it's just showing this stuff because it never overwrote this stuff. Because I keeps going here. Okay, so I shouldn't keep going, unless we're actually storing something. I should only keep going when we're storing something. If I keep going when we're not storing anything, we're gonna see like phantom ends of lines. Okay, this makes much more sense. And now it shows the first one, it doesn't show the second one. So it means that when we found the second one, we actually need to erase the previous one so that the first one also disappears. So if SCC has now reached 2, it means that I need to go back 1 I to write on top of it. Okay, let's try again. Compile, run. Okay, it looks fine. So now any line that ended in a comment, the comment has been removed. Because I'm counting the slashes. If I've already found 2 slashes, I'm not taking the following characters into account anymore. And when I found the second slash, I get rid of the first one. But now what I'm kind of counting on here is for the slashes to be right after one another. If they're not right after one another, my logic will fail. So they need to be, SCC needs to be a 2. So we should only increment it if the preceding character is also a slash here. No, actually, if when it's not a slash, we should return SC to 0. That way I should be able to write stuff like divisions. Where can I write divisions? So, okay. I'm just gonna write some random divisions here for like no reason. I'm gonna write that in here. Let's write that L is going to be 6 divided by 2 multiplying divided. A 4 divided by 2. Okay, so my previous logic would have found this slash and then later this second slash and ignored the rest. So if I don't recompile and I run it, we're now going to have a problem here because the second division is taken as a comment. But since I changed the logic that when I find something that isn't a slash, it resets, if I compile and run again, my divisions will survive. Whereas the, okay, now it also, the problem is that when it gets to the space, it resets again. So it only needs to reset if SC is less than 2. If SC is already 2, it's not supposed to reset. Compile. Okay, now it's fine. Now it's fine. Lovely. So now as an exercise, we should also be able to deal with the comments that have multiple lines on them, like the stuff we added in two-way F over here. We should be able to make comments that endure multiple lines. And now this is more uncomfortable because when a line starts like this, we're going to ignore all the lines until we find one that ends like this. So we're gonna now assume that the comments are written strictly in a way that this will be in the beginning and the other thing will be in the end. And we'll try to deal with that. So after we get the line, if that line contains the beginning, we're not going to print it. So how do I check if a string contains another string? Let's look here. String operations. Pointer, copy, compare, only the first in characters, length off, concatenate. Okay, some of this sounds pretty good. We're going to want them to be substrings, but we don't necessarily know whether those are the first ones. So now some of this comparison stuff might work for us. let's do the thing that any developer is going to do and Google test for substring in C. Check substring exists, blah, blah, blah. str sent word, okay. Marvelous. Now, str comes from where? From C string, apparently. Okay, let's try. So from here, it returns a pointer. So this means that there is a substring. Okay, so if line contains the thing that starts a comment, then it means we start ignoring. If we're not ignoring, we print the line. And we will stop ignoring when it contains the other one. So now I'm going to need a flag for ignoring. Originally, I'm not going to be ignoring. So if we do it the other way around, then we will stop ignoring. And the same line could contain both. If we're not ignoring, we print the line. Okay, let's see how badly I've broken it. Apparently it didn't break. No, not like that. Like this. Okay, so let's see if everything looks fine. Two-way F, what is it supposed to look like? It still printed this line. Okay, because it took the ignore off before it... we first need to check if we print, and then we need to take off the ignore. Let's try again here. No, compile. No. As input. And compare with what it looks like here. So it's, where are we? It took away these two comments, it took away this comment, it took away this whole thing here. It took away this comment. It seems to be working wonderfully. So now, new things that we have had to deal with to do this is checking for substring. Which means whether or not one word contains another word. In this case, whether or not the line contains the combination of a slash asterisk or an asterisk slash. Okay, so we are kind of horribly lagging behind here. Let's add the no comment to the repository. Trying to remember what exercise this was. This was 1-23. Let's close this. And let's go look at the mini exercises. We need to spend maybe 15 minutes. In Hector, in C, single quotes are for characters. For single characters, one single characters. And double quotes for strings and character arrays. Okay, let's Let's try to catch up. Next time, guys, when I ask you to read something, seriously, you gotta read it. And if you're confused and you can't get it done, then you really need to talk about it on Discord. Because me thinking you guys actually read the chapter puts us in a very bad position because you actually didn't read the chapter, and then we are in trouble. So now what we're going to do is we're going to go back to the website, and now is where I might be in trouble because I haven't used this system in ages. So there are tiny little exercises there. So you're going to go to the exercise page, and you're going to write the same email you registered. Remember, you filled in the registry thingy where you put your study program and your student number? You're going to put that same exact email. Like, I'm going to put mine right here. And the very first time you log in, it probably tells you that this is a new account or something like that. But whenever you enter, you always first read, is this the same email you meant to use? Because anytime you enter, you get new exercise if it's not the same email. It has to be the same email every single time. So let's all go there. Put me the green thingy if you are already there, if you're looking at your exercises. Everybody has slightly different exercises, so don't panic. You're not going to have the same ones that everybody else has. It's fine. It's okay. And now, the idea is that you have read the entire chapter and you have understood the entire chapter. If you read and understood the entire chapter, you should be able to, even without writing the code, figure out what's this program going to print. If x takes this value, y takes this value, and z takes this value. So you would put the values here, here, and here. I recommend trying to work it out by hand and then verifying in code. Then, if you put the correct answer, you're going to get points. The second question has another code. These are your A, B, and C. You will put them here, here, and here. It'll print out something. If you type something that is wrong, it'll tell you what you're supposed to be checking. If you type something that's right, it's going to give you 1 point. Then there's a third code. There's going to be an F and a T and an S and an O. Actually, that's a 0. So the F and the T and the S are given here, and you're supposed to write here, what does this program print out? If you actually want to be a programmer at some point, you should be able to work these things out even without running the code. If you just want the points, well, then you're going to do what I'm going to do now to show you how this is done. I'm going to go to the online GDB thing here. I'm going to put the code. I'm going to look at my values. It says F is 3. It says T is 37. It says S is 1. I am going to run my code. I'm going to select the language because I never do. Run my code. It printed 17. Okay, so I'm just going to put here 17. Then underneath there is a grade exercise 1. Now horrible things might happen because this hasn't been used in a long time, but apparently it works. It gave me 1 point for the correct answer. And if I wanted to answer this one, I would just copy it here. A is 40, B is 12, and C is 8. I'm not actually proving that I know anything about programming. I'm just proving that I know how to use this website. So it printed 8. If you actually want to learn, you will figure out with like a notebook and a pencil, why do these programs print these things? But now I have my first 3 points. Nobody is going to write any programs before you actually are able to answer these little exercises because these are tiny and trivial to do. So once we've done these trivial exercises, we are going to do an actual programming assignment. Okay? And this is my suggestion for the actual programming assignment. I need you guys now to go answer those little 3 questions. If there's any trouble, please let me know. Once we've responded to those questions, we will discuss on the voice channel of Discord this thing here. What's my suggestion for the first homework? We can make changes to it, but that's all going to happen before 5 p.m. today. So, whatever you do, make sure it corresponds to what we're doing at 5 p.m. today. Your exercise will be graded next week during class. If you do not get graded before class, we can try to grade you next time. It might be a little easier every week because more and more people give up and they don't show up anymore. But please, let's try to be in class so that you can actually be graded. Since there's like 70 of you, we're going to have to do the kind of stuff we did today. You're going to have to be checking each other, and I'm going to be quickly browsing through everybody's repositories to check whether your code looks okay or whether it looks bad. But the grading's going to happen in class, and your code has to be in your repository. And I would please, please, please beg you, name your file homework1.c. No underscores, nothing else, just homework1.c. So that it's easy to know which one of the files in your repository is actually your homework. And if you could, please, please, please make like a subfolder homework that contains those, so that all the examples and other stuff are somewhere else and the homeworks go in one specific place. It would be much faster and easier to find your code. But please, right now, everybody, answer the 3 little questions. Put the check mark when you've answered the 3 little questions. I'm going to make another poll. If you have something you would like to discuss about the 3 little questions, put the question mark and start typing whatever you want to know. We have to understand these 3 codes. If you don't understand these 3 codes, you will never be able to program the homework. Never. Because I am counting on you to have understood the entire first chapter to be able to do this. If you haven't, you will not be able to do this. It would be a very good idea to try to make friends with other people on Discord so that you could discuss with others when you're programming. You can also use this channel. This channel is for you. So if you want to work on your homework, for example, Saturday afternoon, you can type on this channel, guys, I want to work on the homework Saturday afternoon around 2 o'clock. Please meet me at the voice channel. And then other people who are also working on the homework can log on at the same time and you guys can talk. If I happen to be online and I'm available, I'll do my best to help you. But since I have like 200 students and some of them are not very considerate, could you please try not to ask me at like 9 p.m. why your code doesn't compile? Or like on Sunday afternoon start insisting that I need to show you how to compile the code? It would be really nice if we could do this in my working hours. It would be nice. Yeah, my boyfriend agrees. He says never ever to ask me at night to fix your code. But yeah, that's the point. Collaborate. Don't copy anybody's code, but talk to each other, talk to me. Also, don't ask anybody, hey, what did you put in question 1? Their value is not going to be the same as yours because they have different numbers here. Just ask them how did they do it. But I'm going to stop the recording now. You guys are going to answer these little questions. When I see that 30 people have the green check mark, I'm going to start talking about the programming assignment on the voice channel. I'm just going to chill here and wait until 30 people have answered the little questions. Okay? Stopping the stream and giving you guys the URL in like 1 minute.